Dear students, welcome to the video lecture of the object-oriented system development. In this video, we are going to see a segment of the object-oriented system development. That means over ST life cycle, and we are going to discuss about the introduction, waterfall model, and building the high-quality software. These are all the part of the object-oriented system development life cycle. First, the object-oriented system development life cycle and introduction. The software development process consists of various phases, such as just a minute, such as analysis, design, implementation, testing, and refinement. So these phases transform the user need into software solution that satisfies the need. So some people use software development process as interesting, but feel it as a little important in developing a software. It is not correct. In general, dynamics of the software development provide little room for such shortcuts, and bypasses have been less than successful. You are not following a correct process. If you are developing a software in an ad hoc manner, that will leads to very least successful one. The OOAD approach requires more rigorous process to do right things. So you are not able to see the code in 20% of the development time. The reason is you have to spend more time in gathering your requirements and developing a requirement model and analysis model and turning them into a design model. The software development process contains a three type of transformation. The first transformation, the system uses are captured, they are transformed into structured problem statements and analysis. The transformation two, problem statement analysis are transformed into design, implementation, and detail. In transformation three, the design, implementation, detail are transformed into the system, software, and the product. The software development process. The software development process can be divided into smaller interacting sub-process. Generally, software development can be seen as a series of transformation, where the output of the one transformation is become the input of the subsequent transformation. See the previous slide. The output of the one transformation is the input of the subsequent transformation. So the output of the first transformation is the input of the subsequent transformation. The transformation one analysis. The transit the user need into system requirement and responsibilities. The way they use the system can provide an insight into the user requirements. For example, one user system might be analyzing an incentive payroll system, which will tell us the capacity be included with the system requirements. Transformation to design. It begins with the problem statement and ends with the detailed design that can be transformed into an operational system. So begin with the problem statement and ends with the detailed design. The transformation includes bulk of software development activities, the definition of how to build the software and its development and its testing. It includes the design descriptions, the programs, and testing material. Transformation 3 implementation. It refines the detailed design into a system deployment that will satisfy the user need. It takes into account the equipment, procedure, people, and others, other elements of the final software. It represents embedding a software product in its operational environment. Okay, it fit the software product into its operational environment. This is the transformation 3, that is implementation. Yes, a waterfall model. Waterfall model is a very traditional model. It is known as a step-by-step approach. So you are able to complete a one phase and then only you are able to go to the next phase. You cannot reverse in the waterfall model. An example of the software development process is a waterfall approach. It starts with deciding what has to be done. Once the requirements has been determined, all the requirements are freezed. We must decide how to accomplish the requirement, This is followed by a step in which we do it, whether it has required us to do. We must test the result to see if we have satisfied the user requirement. Finally, we use what we have to done. So what is developed is to be used in the final step. So see, it is step-by-step approach. First, what is to be developed? Once the requirement are freeze, then how it is to be developed, then implement it, then test it and use it. You are not able to go back to the previous step. This is one of the drawback of the waterfall model. Next, building the high quality software. The ultimate aim of applying the object-oriented system development is to building high quality software. The process transforms the user need via application domain to a software solution that satisfies those needs. High quality product must meet the user need and expectation. High quality product means that the product it meets the user needs and expectation. Then we can claim that it is a high quality product. Otherwise, we cannot claim it is a high quality product. Furthermore, the product should attain this with a minimal or no defect. That focus being on improving the product or services prior to the delivery, rather than correcting them after the delivery. So you have to improve the quality before prior to the delivery. After you want to improve after the delivery, it is very difficult to make changes, or the changes are costly. The ultimate goal of building high quality software is user satisfaction. To achieve high quality software, we need to answer the following question. Once the system is ready, you have to answer the following question. How do we determine whether the system is ready for delivery? How you are deciding the system is ready for delivery? Second, is it now an operation system that satisfies the user's need? Okay, whether the operation system which satisfies the user needs. Third one is it correct and operating as thought it should, as it is working as intended? Do it pass an evaluation process? Whether we carried out the evaluation process, whether the software passes the evaluation process. So these questions should be answered. If the answer is yes for all the questions, then we can assume that we are developing a high quality software. There are two basic approach to system testing. We can test the system according to how it is to be built, or alternatively what it should do. Okay, there are two methods. You have to test the system how it has been built, or what it should do. Bloom described a mean of a system evaluation in terms of 4 quality measures: correspondence, correctness, verification, and validation. So these 4 quality measures are used to evaluate the software. First one is correspondent. Correspondent measures how well the delivered system matches the need of the operation environment as described in the original requirement statement. That is known as a correspondent. The validation means a task of predicting the correspondence. True correspondence cannot be determined until the system is in place. Next one is correctness, which measures the consistency of the product requirement with respect to the design specification. Next one is verification, is the exercise of determining the correctness. However, correctness always is subjective. The next one is validation. However, is always subjective and is address a different issue. The appropriateness of the specification is addressed in the validation. Boehm observed that these quality measures, verification and validation, answers the following question. Verification, it states, am I building the product right? Validation stands for, am I building the right product? So validation begins as soon as the project starts, but verification can begin only after the specification has been accepted. Verification and validation are independent of each other. It is possible to have a product that corresponds to its specification, but the specification proved to be incorrect. We do not have the right product. For example, the right product means if the product is satisfy the user need, the product is developed as per the expectation of the user, that is known as a validation. Verification means whether the product is developed based on the requirement specification. It is possible that we are able to capture the requirement, or we make some mistakes in the requirement specification and we develop the product according to the requirement specification. So in this case, that the product may pass the verification, but the product may fail in the validation. Okay, thank you for watching the video lecture. Thank you.